Hi, this is Mr. Mack. This is a concept video, and it deals with solving rational equations and inequalities. Now, rational equations are equations that contain ratios. And let's start off with the fact that anytime you have a fraction, if you multiply the denominator of that if you multiply that fraction by a multiple of the denominator, your answer isn't a fraction. So let's take a look at a couple of examples. Let's say we have the fraction 1/5. If you multiply 1/5 by 5, you get 1. 1/5 times 10, you get 2. 1/5 times 25, you get 5. 1/5 times 130, you're going to get 26. So any multiple of 5 multiplied by 1/5 will give you a number that isn't a fraction. Now, we make use of that fact to solve rational equations. And let's take a look at a simple example. Let's say we have the equation 7 over x plus 2 plus 1/6 is equal to 5/2. Now, if you look at this equation has denominators of x plus 2, 6, and 2. So the lowest common denominator, which is also the lowest common multiple of those fractions, is 6 times x plus 2. So since I have an equation, I can multiply both sides of this equation by 6 times x plus 2, and what will happen is the denominators, I'll get larger numbers, but I'll get numbers that won't be fractions. So see, I have 7 times x plus 2, and I'm multiplying that by 6 times x plus 2. Let's make that over 1, plus 1/6 times 6 times x plus 2 over 1 equals 5 over 2 times 6 times x plus 2 over 1. Now, in each case, something will cross cancel. In this first one, the x plus 2's will cross cancel because they're both factors. In the second case, the 6's will cross cancel. And in the last case, the 2 will cross cancel with the 6, leaving a 3. So my equation now becomes 42 plus x plus 2 is equal to 15x plus 30. See, I multiplied the 5 times the 3, and then I multiplied that by x plus 2. Now, to solve this equation, we'll get all our x's on one side and all of our numbers on the other. So we end up with 14 is equal to 14x, x equals 1. Okay, now let's go back and check to see if this equation actually does work when x is 1. Well, to check, the left-hand side of the equation is 7 over 1 plus 2 plus 1/6. Well, that's 7/3 plus 1/6, which is 14/6 plus 1/6, which is 15/6. And 3 goes into both 15 and 6, 5/2, and that's what we had on the right-hand side. So it does check. So x equals 1. So the technique for solving rational equations is to find the lowest common multiple, also known as the lowest common denominator, of all the denominators and multiply both sides of the equation by that so that you get an equation that doesn't have denominators. Now, one thing you do have to worry about or have to watch for is that these equations will sometimes generate extraneous solutions, because notice, if we go back to this one, notice we did cross out an x plus 2 in the denominator with an x plus 2 in the numerator here. Now, if it turned out that x was -2, that would work in one of the transformed equations, but it wouldn't work back in the original, and we'd have to throw it out. So you always have to check to see if any of the solutions you've generated make any of your denominators 0. If they do, that particular solution, if there's more than one, has to be thrown out. And if that's the only one, then your equation isn't going to have a solution. Let's take a look at an example of that. How about the equation x over x minus 3 plus 20 over x squared minus x minus 6 equals negative 4 over x plus 2. All right, now, first of all, if we factor this denominator, this factors into x minus 3 times x plus 2. So the lowest common multiple is x minus 3 times x plus 2. So what I'm going to do is I'm just going to write that. Oh, by the way, there we go. I'm going to write that out here. X minus 3 times x plus 2 over 1. Now you kind of have to follow through with this. First fraction, x over x minus 3 times x minus 3 over x plus 2. Notice the x minus 3's will cancel, and we're left with x times x plus 2. Now for the second fraction, the x minus 3's will cross cancel, the x plus 2's will cross cancel, and we're left with just 20. Now on the other side, notice the x plus 2's will cross cancel, and so we have negative 4 times x minus 3. And now some algebra needs to happen. Let's see what goes on here. We got x squared plus 2x plus 20 minus 4x equals negative 4x plus 12. Okay, and when we add 4x to both sides, this is a quadratic equation, so we have to solve by getting everything to one side and subtract 12 from both sides. We get x squared plus 6x plus 8 equals 0. Now that factors into x plus 2 times x plus 4 equals 0, which x plus 2 equals 0 gives us x equals negative 2, or x plus 4 equals 0 gives us x equals negative 4. Now, if we go back and look, do either negative 2 or negative 4 make any of the denominators 0? Well, negative 2 does make this one 0. It actually makes this one 0 as well. So we have to get rid of the x equals negative 2. It's an extraneous solution. So the only solution to this equation is x equals negative 4. So as you're solving these, that's the procedure that you use, and don't forget to check to make sure that you don't have any extraneous solutions. Now, as a little piece of advice here, I'll just say to you that if you were doing a problem in the real world, there's probably not a great chance that you're going to get an extraneous solution for a rational equation like this. But when math teachers and Pinellas County supervisors and so forth write tests many times, they are going to include an extraneous solution because it's not difficult to write an equation that has one. So make sure you check. Now, we're also going to take a look at some problems, some actual word problems that are solved using this concept of rational equations. So what I'm going to do here is I'm going to pause and write the problem. Hi, I'm back. Now, here's the question before us. How much 60% acid solution must be added to 10 milliliters of a 20% acid solution to create a solution that is 50% acid? All right, now what we're going to do is we're going to say we want our final result, we want to be 50% acid. So we want 50% to be, and what we're going to have is the amount of acid over the amount of solution. You see, if we divide the amount of acid by the total amount of solution, acid and water, we'll get 50% in our resulting solution. Now, when we're doing a problem like this, it's always a good idea to start out and identify the unknown. And it's pretty easy. In this case, how much 60% acid solution must be added to a 10 milliliters, et cetera, et cetera, et cetera. So let's let X, it's always a good idea to write this down also. Let's let X equal the amount of 60% solution added. Now, now what I want to do is I want to express in terms of X the two quantities, the amount of acid and the amount of solution. Now, how much acid will we have? What's the amount of acid? Well, we already have 20% of means multiply, 10 milliliters is acid. So 0.2 times 10 equals amount of acid we already have. Now stop and think about that with me for just a second. We have 10 milliliters of solution that's 20% acid. So 0.2 times 10 is the amount of acid. Now it's easier to just write 0.2 times 10 is 2 milliliters. So we have 2 milliliters of acid already. Now how much acid are we going to add? Well, we're going to add X milliliters, but only 60% of that is going to be acid. So the amount added, acid added, will be 0.6x. In other words, 0.06. There's 60% of the amount added is actually solution. So if we go over here, we have, and by the way, 50%, we can just write that as 0.5. That's going to be equal to 2 plus 0.6x over. Now, how much solution did we have? Well, we started with 10 milliliters of solution, and we're going to add X milliliters of solution. So we get 0.5 is equal to 2 plus 0.6x over 10 plus x. Now, notice in this equation, by the way, let me just, now that we've done this, let's group all this and just make it a little bit smaller over here so that we have a little room to work with the equation here. Now that we have the equation, we want to solve this equation. Now the easiest way to solve this equation is to find the lowest common multiple of all the denominators, which in this case is just 10 plus x, and multiply both sides of the equation by that, like we did in the last one. So I get 10 plus x over 1 times 0.5. That's 5 plus 0.5x equals, now on the right-hand side, the 10 plus x's cancel. We get 2 plus 0.6x. All right, so what shall we do? Let's get all the x's on one side. I'll subtract a 0.5x from both sides, and we'll get all of the numbers on the other side. I'll subtract a 2 from each side, so that gives me 3 equals 0.1x. So if I divide by 0.1, I get x is equal to 30. So the answer is we should add 30 milliliters of a 60% acid solution to 10 milliliters of a 20% acid solution to get a solution that is 50% acid. All right, now the next question that comes up is distance problems. So once again, I'm going to pause while I write the problem up, and then I'll get back with you. So I'll be right back. Hi, I'm back. All right, now here is a rate times time equals distance problem. In fact, it's always a good idea to just start out and say rate times time equals distance. Okay, and then a lot of times the relationship will come either from the idea that two expressions add up to make a distance, or two expressions add up to make a time, or something like that. But rate times time equals distance is going to be a very important concept to use to solve these things. Now here's the problem. Sandy rode 12 miles upstream and then 12 miles back downstream to her starting point. If the current of the stream is 3 miles per hour and it took a total of 2 hours to return to her starting point, how fast can Sandy row in still water? Okay, now you need to think about this with me. For example, first of all, what we would like to know is how fast Sandy can row in still water. So let's let x equal Sandy's rate in still water. Now, you're going to have to think about this for a minute, but it should make sense. And this works with boats in water, airplanes in wind, all that kind of stuff. If you are, let's say you're in a boat and you're rowing against the current, the speed that you are actually going according to the current, according to the shore, is going to be how fast you can row in still water minus the speed of the current, because it's pushing against you. Now, if you turn around and you go with the current, the speed that you are going relative to the shore is going to be the speed that you row in still water plus the speed of the current. So when she's going upstream, her rate relative to the shore is going to be x minus 3. Now, when she's going downstream, her rate relative to the shore is going to be x plus 3, because that 3 miles is going to be the other way around. Now, we could express the time that it takes you to get upstream, because if we have rate times time is equal to distance, time is equal to distance divided by rate. And we're going to use that. So her time up, I'm going to use it T sub u. Her time up is going to be the distance, which is 12 miles, divided by her rate up, which is x minus 3. And her time coming back downstream, T sub d, is going to be, again, the distance going downstream, 12 miles, divided by the rate downstream, which is x plus 3. Now, so the time up plus the time down is going to be 2 hours. If you look back there, it took a total of 2 hours to return to a starting point. So the time up plus the time down is equal to 2 hours. 12 over x minus 3 plus 12 over x plus 3 is going to be equal to 2. And there's the equation. Now, notice it seemed to happen pretty easily because we used rate times time is equal to distance. And then we expressed things in terms of the variable we wanted to know. We expressed things in the terms of Sandy's rate in still water. Okay, so now we need to solve this equation. Notice that the lowest common multiple of both these denominators is x plus 3 times x minus 3. So I'll multiply both sides of the equation by that. Well, in the first fraction, 12 over x minus 3, the x minus 3's will cancel. We have 12 times x plus 3. In the second fraction, the x plus 3's cancel, and we get 12 times x minus 3. Now on this side, we get 2 times x plus 3 times x minus 3, because there's nothing to cross cancel. And now algebra happens. 12x plus 36 plus 12x minus 36 equals 2x squared minus 18, because x plus 3 times x minus 3 is x squared minus 9, and then when you multiply by 2, you get 2x squared minus 18. If you had trouble with that, stop and do the math yourself. I'm sure you'll be able to get it. Now, this is a quadratic equation because we have an x squared that doesn't look like it's going to go away, so I'm going to move everything to the same side. Well, first of all, plus 36 minus 36, those go away. And so I have 24x on the left-hand side. I'm going to subtract 24x from each side. I get 0 is equal to 2x squared minus 24x minus 18. Now, at this particular point, I want to solve this quadratic equation. And let me just say again that it always makes sense to look at problems and see, is there any way I can rewrite this to make it not as complicated. And see, this 2 here is a bit of a problem. So we could just divide through by 2. We get 0 is equal to x squared minus 12x minus 9. Now, oops, this is not going to factor. So we're going to have to use the quadratic formula for this one. So what do we got? We got x is equal to 12 plus or minus the square root of 12 squared minus 4 times 1 times negative 9 all over 2. Well, 4 times 1 times negative 9 is negative 36. 144 minus negative 36, or 144 plus 36, gives us 12 plus or minus square root 180 over 2. Now, if you didn't know, you could figure this out, but the largest factor of 180 that's a perfect square is 36. So this becomes 12 plus or minus 6 square root 5 over 2. And since there's a factor of 2 in the numerator and denominator, it becomes 6 plus 3, plus or minus 3 square root 5. Now, x represents Sandy's rate in still water. The square root of 5 is bigger than 2, and so 3 square root 5 is going to be bigger than 6, and so if we subtract that, we're going to get a negative number. So we'll just throw this one away, and so we get 6 plus 3 square root 5. Now, if you want an approximation of that, you could take your calculator. Where is my calculator? Here it is. And just do 6 plus 3 root 5, and we get 12.71. So Sandy's going at about 12.71 miles per hour. That's pretty good rowing. All right. You'll get a chance to try some of those distance problems. Now we also have the work problems. I did one of these in AR, but let's just go back and take a look at it again. Let's just use the same one because I like this one. Sam can paint a house in 3 hours. Joe can paint the same house in 5 hours. Working together. How long will it take to paint the house? Once again, let's start with the unknown. What do they want to know? What are we being asked for? Well, we're being asked for the time it would take them to paint the house together. So let's let x equal time together. Now, if you'll recall, this is still a rate problem. Rate times time is equal to distance. And if you'll recall, if Sam paints a house in 3 hours, his rate of painting the house is 1/3 of a house per hour. So Sam will paint 1/3 of a house per hour times x, the number of hours he's painting on the house. And Joe will paint 1/5 of a house per hour times the number of hours he paints. And together, Sam and Joe will paint the house. So we have 1/3 x plus 1/5 x is equal to 1. Now, once again, this is a rational equation because we have x over 3 plus x over 5 is equal to 1. The lowest common multiple of 3 and 5 is 15. So if we multiply 15 by x over 3, we get 5x. If we multiply x over 5 by 15, we get 3x. And if we multiply 1 by 15, we get 15. So 8x equals 15. X equals 15/8, or 1 7/8 hours. And this is a problem that we actually had already done once in AR. So those are the different types of problems you'll probably see. I also in AR did one about investments, but that percentage, that's the same thing as the mixture problem. So I won't put another one of those in here in the concept video. One more thing we need to talk about is rational inequalities. Now, when you have rational inequalities, you're looking for the range or ranges where the inequality is true. And let's just take a look at an example. X over 5 minus 1 over x minus 3 is less than x plus 2 over 6. Now, the problem with the inequalities is we don't really know. If we multiply both sides of this inequality by x minus 3, we don't really know if x minus 3 is positive or negative. If x is 2, x minus 3 is negative. If x is 4, then x minus 3 is positive. So we need to be able to handle this in a different way. Now, what we've got is we have, and this is a general concept, whenever you have an inequality, it turns out that all the numbers to one side or the other side of an endpoint will work. So what we can do with this is we can actually just first solve the related equation. Now the related equation is x over 5 minus 1 over x minus 3 is equal to x plus 2 over 6. Now, once again, also, whenever you have this minus sign here, just do that right at the beginning, or it might end up biting you. Okay. Now, once we have found the x's for this, we need to go back and look at them on the number line and check all of the intervals that this gives us, and see which ones actually work. And those are the ones that we'll report as the solution. So here, I think you'll notice, or you'll recognize, that 30 times x minus 3 is the lowest common multiple. So we'll multiply both sides by 30 times x minus 3. Now, x over 5 times 30 times x minus 3, the 5 will cross cancel in the 30, leaving 6x times x minus 3. Now, in the second one, the x minus 3's will cancel, and we'll be left with negative 30. Now, on the right-hand side, the 6 will cancel with a 30, leaving a 5, and so we have x plus 2 times 5 times x minus 3. And now some algebra needs to happen. So we get, what, 6x squared minus 18x minus 30 equals, now, x plus 2 times x minus 3 is x squared minus x minus 6 times 5 is 5x squared minus 5x minus 30. Okay, now this is going to be a quadratic equation, so we'll solve both sides here. We'll, first of all, we'll subtract 5x squared from both sides. We'll add 5x to both sides. And we'll add 30 to both sides. That was nice. And so we end up with the quadratic equation x squared minus 13x equals 0. Now this can be solved by x times x minus 13 equals 0. So we get x equals 0 or x minus 13 equals 0, in which case x equals 13. Now there's one other thing that we do have to look at here, all right? Because if we go back to the original inequality, this denominator is going to be 0 when x minus 3 is 3. So x minus 3 cannot be 0, so x is not equal to 3. So those are the values that we're going to take a look at on the number line. So if we draw a number line, we have 0, we have 3, and we have 13. Now notice, since this inequality is strictly less than, none of these points will actually work. But we do need to check the values in this region, this region, this region, and this region to see which one or ones of those actually do work. So let's start with this one over here. If we put -1 in, we get -1/5 minus 1 over -4, and then on the other side we have 1/6. Well, this is going to be plus -1/5 plus 1/4 is going to be 1/20, and we have 1/6 over here. Now 1/6 is bigger than 1/20. Did I do that right? I think I did. Yeah. -1/5 plus 1/4 is 1/20, and we have 1/6. 1/20 is greater than 1/6, so we do want this region here. Now, if we try this region in here, let's try using 1, for example. That's in the second region. We get 1/5 minus 1 over -2, and on the other side we get less than 3/6. Okay, so this becomes plus 1/5 plus 1/2 is less than 1/2. Well, 3/6 becomes 1/2. And if we add 1/5 to 1/2, we're not going to get something that's less than 1/2. So we don't want this region here. All right, now let's try a number between 3 and 13. Is there a nice one? How about 5? Let's do 5. 5 over 5 minus 1 over 2 is equal to 7/6. Okay, 1 minus 1/2 is equal to 7/6, is less than 7/6. Well, 7/6 is bigger than 1, so if we subtract 1/2 from 1, we're not going to get something that's, well, wait. Okay, 1 minus 1/2 is 1/2. 1/2 is less than 7/6, so we do want that region, so we'll take the region from here to here. And then finally, let's try something bigger than 13. How about, 20? So we have 20 over 5, which is 4, minus 1 over 23. No, 1 over 17. 20 minus 3 is 17. 4 minus 1/17 is less than 22 over 6. Well, 22 over 6 is 3. This, by the way, is 3 and 16/17. And this is going to be 3 and 4/6. And it's pretty obvious that 4/6 is less than 16/17. So we would say, no, we don't want this region over here. So our solution is going to be x is less than 0 union 3 is less than x is less than 13. And so that would be how you would solve a rational inequality. Remember, not only do you have to find the solutions to the related equation, but you also have to include anything that makes any of the denominators 0. And that takes care of rational equations and inequalities.